before I start the lecture, any of you have any questions about homework 9 or quiz 3 or your exam on Monday?
Is it the exam on Mondays?
Yes. Just a class time, normal, usual, but you, instead of me lecturing, you will be taking the test. Okay, if no questions, just remember to do homework 9 and quiz 3 before 11:59 p.m. tonight. And just don't let it, don't do it at the 10 p.m. or 11 p.m. just in case something happens, just take it sooner, right? Why wait that long? Okay. So if no question, as usual, I have the periodic table to make sure that you're familiar with the atomic symbols and also kind of have that, so you are comfortable with that. So if I ask you, what is the molar mass of one chlorine atom? What is the answer? Anyone? 35.45, right here. So this number is atomic mass, and the unit is AMU, atomic mass unit, but it also is equivalent to molar mass. So it would be 35.45. So this is atomic mass unit, right? And it is also molar mass, and the formula, or the unit rather, is gram per mole. So if I tell you which of the following is formula mass for the compound NaCl, what is the unit of formula mass? Anyone? AMU, yes. So it's atomic mass unit. But if I tell you what is molar mass of NaCl, what is the unit of this? Exactly, grams per moles. So the numbers numerically are the same, but depending on what I ask you, it would be AMU, atomic mass unit, or gram per mole. Everyone's comfortable with that? And also, again, in the table that I give you on Monday, it's not color-coded, it's not clear which elements are metal, which ones are non-metal. So at this point, I think most of you are comfortable with metals, non-metals, right? So if you have this zigzag here, these elements, they are metalloids, right? And the elements, above them, or rather like this, you see? And I guess above to the east and north, kind of, these guys here that are denoted by green here. They are nonmetals and also hydrogen. Other than that, the rest of the elements are metals. Are we comfortable with these? So if I tell you, is the following statement true or false? Chlorine atoms can form cations. Is it true or false? False, exactly. Nonmetals gain electrons, metals lose electrons. And cation is an atom or species that they lost electrons, they gained positive charge, right? And also anions are atoms or species that they gained electrons and now they have negative charge, okay? So if I tell you Cl minus, this is an anion because it has negative charge here, right? Or if I tell you OH minus, this is a polyatomic ion, but specifically is anion because it has negative charge. But for instance, ammonium NH4 plus is a cation. It's a polyatomic ion, but because it has positive charge, is a cation. Are we comfortable with cations and anions? Yes?
So it's dependent on whether or not it's a metal?
Exactly, yes.
So is it like metals form anions, like cations?
Metals form cations, yes.
And then the other two things, non-metals and metalloids, they form anions?
Exactly, yes. And most of the time there are nonmetals. We can have metalloids too, rarely. But in general, nonmetals gain electrons. So the only, almost all the metals or all the cations that you see, they are metals. They have been metals that they lost electrons. The only exception is ammonium, which is a polyatomic ion, and it's like nitrogen and hydrogen atoms bonded together, and that unit itself lost one electron and formed a cation. That's why when we talk about ionic compounds, we say they form between cations and anions. Because if I only say metals, nonmetals, you may say, what about NH4OH, ammonium hydroxide? This one is an ionic compound too, but it doesn't have any metals. Does that make sense? So this is the only exception, the cation that, so an ionic compound that forms between a cation and anion that doesn't have any metal. Other than that, all other examples that you encounter in this course would be metal, nonmetal. So if you see metal, nonmetal, that is an ionic compound. Is that clear? Any questions? The other question that I asked you in your homework quiz, and I'm going to ask you in the exam, I say, for instance, just consider this example here, NH4OH. First of all, you should be able to name them, and also, or like this compound and other compounds. And also I say, how many elements exist in NH4OH? Can anyone tell me how many elements do you have in ammonium hydroxide? What's that?
Is it 3 or is it 4? There's 2 H's.
But although there are 2 H, but they are still hydrogen, right? So we consider that one element. Exactly, you have 3 elements. You have nitrogen, hydrogen, oxygen, right? But if I ask you in NH4OH unit, how many atoms do we have? What would be the answer? Exactly. So you have 1 nitrogen, 5 hydrogens, and 1 oxygen. Does that make sense? Yes? Any questions?
You said for the exam we're going to have to memorize the names of different compounds, or like for NH4+, got to remember that that's ammonium?
So I give you the table of polyatomic ions.
Okay.
So to help you for the exam, so you don't have to worry too much about which was like chromate, which was what chromite, nitrate, nitrite. I don't want you to stress about that. So I give you that table. But you should be able to use the table to name the compounds. Great question. Any other questions? Good? Okay. Now I have like some slides to review things, and then I have some examples to make sure that you understood the materials, and then I'm going to basically start new materials. So can anyone tell me, if I say 1 mole of people, what does that mean? Exactly, it means like this many people, 6.022 multiplied by 10 to the power of 23. So I gave you an example of pennies, that 1 mole of pennies covers the entire Earth's surface to the depth of 300 meters. So 1 mole of people, it's like unimaginably large, probably just like go to the Milky Way, people like in space. Anyway, it's just like really, really large number. I just want you to have an idea how big this number is. But practically, or like not practically, technically, we can have that. right? So this is only a number, it's like dozen. If I say dozen of books, it means 12 books. If I say dozen of trees, it means 12 trees. And this is also a number. It can apply to any other concept. Sometimes I trick students. I say mole is a concept that can only be used for atoms on molecules and compounds or in chemistry. This is a number. It can be anything, okay? So if I ask you to calculate number of molecules, you say 1 mole of that compound or molecule would be 6.022 multiplied by 10 to the power of 23 of that molecule. And I expect you to know this number, and I repeat it several times during the class, so you'll be more comfortable with that. And sometimes in exam and your homework problems, I say this number to the multiplied by 10 to the power of minus 23. That number would be extremely small, almost 0. So don't get tricked, I guess. So are we good with mole, that 1 mole means? Any questions? Okay. The other thing that we learned in the last sessions is molar mass. Molar mass of an element is mass of 1 mole of that element. If I say molar mass of sodium hydroxide would be mass of 1 mole of sodium hydroxide. And the unit is gram per mole. Okay? So for elements in the periodic table, you simply look at the atomic mass unit that is listed below the element, read that number, and that number would be molar mass. Okay? For compounds, you calculate the formula mass. Remember, for instance, if I have NH4, or like if I have rather NH3, right? You say that, okay, I have 1 nitrogen. If I don't write anything, it means that subscript is 1, right? 1 nitrogen plus 3 hydrogen. And then I read this number, 14.01 in periodic table. And then for hydrogen is, I just had that here, 1.01. And then 3.03 would be 17, if I can write, 0.04. And what is the unit of molar mass? Grams per mole, exactly. So it means 1 mole of ammonia, 1 mole of NH3 has the mass of 17.04 grams. And if I tell you, is the following statement true or false? 1 mole of NH3 has mass of 17.04 atomic mass unit. True or false? False, right? When you're talking about molar mass, the unit is gram per moles. If you're talking about formula mass, the unit is atomic mass unit. But we don't mix them together. Any questions? Yes?
So what's the one again that the unit is moles per gram?
So moles per gram is the reverse of molar mass, and we use that to solve the problems.
Oh.
Yeah. Great question. Any other questions? And as long as you write the conversion factors, you don't need to memorize anything. That you, in this step, you should multiply by molar mass, or you should divide by molar mass. If you write the conversion factor, and we have examples, so don't worry about that. If you write the examples, it would be, if you write the conversion factors, you can find where you should write mole in the numerator or denominator, and the same thing with gram and converting moles of the elements. Great question. Any other questions? Okay. And finally, we said that if we want to convert moles of a compound, or like relate mole of the compound and moles of constituent elements, we just look at the chemical formula. So if I, for instance, look at CO2, and I asked you how many moles of carbon is present in 1 mole of CO2. What is the answer? Exactly, we have 1 mole of carbon. So you just count the number of atoms, right? So how many moles of oxygen do I have in 1 mole of CO2? 2, right? CO2. Any questions? So now, the other thing that we talked about was how to convert the grams of our compound to grams of constituent element. So how we do that? First, we convert grams to moles with molar mass. And as you see here, this is the reverse of molar mass. But as long as you write the conversion factor, you know that grams should be in denominator, so cancel out with this gram here, right? And then you convert moles to moles by the help of chemical formula, right? So you say in 1 mole of NaCl, you see that when we don't write anything, it means that 1, right? You have 1 Na atom, 1 Cl atom. So in 1 mole of NaCl, you have 1 mole of Na. With this conversion factor, with the chemical formula, you convert moles to moles. And then finally, you convert moles of your constituent element to grams of that constituent element with molar mass. And then this mole with this mole cancels out, and then you find grams. So this is the general procedure, and we're going to solve some problems to make sure that we know that. So to summarize what I just reviewed from our previous session, if you know 3 things, you can answer all questions in this chapter. The first one is molar mass, that the unit is gram per mole, and again, you look at the periodic table, read the number below each element, or underneath each element, and if you have a compound, you calculate formula mass. So you count the number of atoms in the compound and multiply that by their atomic mass unit, which is basically their molar mass as well. And then formula mass has a unit of AMU, but molar mass has a unit of gram per mole. The second thing is that you can relate moles of an element and moles of a compound, or like moles of a compound and moles of its constituent elements by chemical formula. You simply look at the chemical formula and then see how many atoms of each constituent elements you have, and that establishes a relationship between mole and mole. And the other thing is that if you know Avogadro's number, you have some questions in your exam that they ask you how many atoms do we have in this compound, or how many oxygen atoms we have in this specific compound, or how many molecules exist in this much of the compound. So if you know 1 mole of anything is 6.022 multiplied by 10 to the power of 23 of that thing, you can establish a relationship between moles and number of atoms or molecules. It can be also polyatomic ions, it can also be books, it can also be pennies. So remember, 1 mole of anything is 6.022 multiplied by 10 to the power of 23 of that thing. Any questions so far? Good. Okay. So something that I did in my previous class, and students loved it, and I'm going to do in this class too, I'm going to assign extra credits for students who volunteer to come solve some problems on the board. So any volunteers to solve this problem, and you don't have to answer the question correctly, as long as you just come here and then give me your thoughts and we solve that together. Any volunteers? Yes.
So I go up to the chalkboard?
Yes. You can better use, yeah. I guess you can use this. Can everyone see in here? I mean, this part of the board? How many of you cannot see this part of the board? If I just go the other. Okay. Is this in front of you? Can you see that though? Okay, good. Can you also explain to your friends how you solve the problem?
So I'm going to do the molar mass of the entire compound.
Uh-huh.
So it would be 2 times the molar mass of iron, which is a little over 55.
Yes.
Plus 3 times the molar mass of oxygen,
Uh-huh.
which is a little over 15, or a little under 16.
Mm-hmm.
And so in 1 mole of okay, so this would be,
I can just give you the answer.
this would be like 158.845.
Uh-huh.
159.6. Somewhere close to that.
Yeah.
In 1 mole of this molecule.
Yes.
So then I do 79.2, which is what we have, divided by 159.69. And that should tell us how much of a mole we have of that compound.
Mm-hmm.
And then I'll multiply that by the molar mass of iron.
Okay.
So whatever this comes out to be, I believe, should be the grams of iron in that.
Okay. Can you also write this again here so students, so your friends can see, and also write the units. So if we see, and also the compounds or like elements, so we make sure that we have the right thing. So when we want to find, stand here so I can also record myself. So when we want to calculate the molar mass of the compound, as your friend is writing, we see how many iron atoms we have in 1 mole of Fe2O3, and also how many oxygen atoms. We have 2 iron, we have 3 oxygen. So we look at the periodic table, we see that Fe is like in group 8b, is like, or like in group A in general, rather. 55.845, and then for oxygen, this number is 16. And depending on what table you use, the numbers might be slightly different, but in the exam, I give you the table, so you don't have to worry about it. So the answers are consistent. So you have like 2 of iron, 3 of oxygen, and then you find the molar mass of the compound. So can you also write what is this compound? So you have what? So you have 79.2 grams of Fe2O3, right? In the next step here, you write how many grams of iron is in 79.2 grams of Fe2O3. And then you convert grams to moles Fe2O3 with the help of molar mass, right? You say 1 mole of Fe2O3 has that much of, which is like 159.70 when you do the calculation, right? So now you have moles of Fe2O3, right? But what do you want to find? You want to find moles of iron, right? So how would you convert moles of Fe2O3, basically iron 3 oxide, and you should know the name too. How do you convert moles of Fe2O3 to moles of iron? Do you remember?
So, yeah, so this is the moles, so then we have Fe is 55.845 grams per mole.
Uh-huh.
So if we, and there are two of those,
Okay.
the compound. So if we multiply that number by it, by 9.69 moles,
Mhm.
we should cross out the moles also and then look at the grams. So this number times 2 times that number.
Okay. So this number till here multiplied by 2 would be moles of Fe, right?
Yeah.
So, and then you convert moles to, so you convert moles of Fe to grams by molar mass, because 1 mole of that has this much of mass. Does that make sense for everyone?
So is that correct?
Yes,
Okay.
exactly. Okay, thank you. What is your name?
Mario.
Oh, okay. You can clap if you want. Okay, so, yes.
Are you gonna, can you continue to write it out here?
Yes, I already did.
Oh, nice.
So,
Okay.
and for people at home who couldn't come to the lecture, sadly, today, and they cannot see what your friend wrote, I also have the solution here. So in general, again, remember that I always encourage you to write both the units and also your compound or element so you don't miss a step. So your friend knew the solution, but he was just making a mistake, not converting moles of the compound to moles of a constituent element. So if you write that, you minimize the error. So again, if you have like how many grams of Fe equals this much grams of the compound, right? Remember, you cannot convert gram to grams directly unless I give you mass percent composition. So I say this compound is 79%, for instance, iron. This is not correct, what I'm saying, but imagine I tell you the mass percent composition. That is the only way or the only time that you convert gram to gram directly. Other than that, 99% of the time, you should convert grams to moles by molar mass, convert moles to moles by chemical formula, and moles to gram, again, by molar mass. So here, if I want this gram to cancel out, if I want to convert that to moles, I should use molar mass, and then I should write grams in denominator so it cancels out with numerator here, right? And then I have moles in numerator, right? In the next step, I convert moles of iron 3 oxide to moles of iron by chemical formula. You just look at Fe2O3. It tells you that 1 mole of this compound has 2 moles of iron in it, right? And finally, you convert moles of iron to grams of iron with molar mass, which simply you can just, I also have these guys written here for better demonstration. So you know that 1 mole of Fe has a mass of 55.85. And then you do the math and find grams of Fe. Is that clear? And remember to write all these when you're putting that in the calculator. Even when I'm writing your quiz, homework, exam, sometimes I forgot to write a number and then I get a wrong answer. So make sure to have all the numbers checked, that you put everything in your calculator. And then again, molar mass, as we mentioned several times, you calculate formula mass, but the unit would be grams per moles. And then you count the number of atoms here, multiply by molar mass of that specific element. Any questions so far? Is that clear? Good. Okay. Any other volunteer for this question? And as I said, don't be afraid to, answer a question wrong. As long as you, dare to come here and then start solving the problem, I give you 5 points extra credit. And right after the class, I go to your exam or like quiz, depending on, what you're lacking, and I add the grades to that. Anyone? Nobody needs any extra credit in this class? Okay. Okay, I mean, if nobody else wants to volunteer, but anyone else? I help you to solve the problem as long as you volunteer. Yes?
It's going to be wrong. I'm very confident.
That's fine. I just want students to don't be afraid to come to me, ask questions, or like come solve the problem. So we want to learn together. So
Could you walk through it?
okay, let me first erase this. Okay. One of them writes, one of them doesn't write. Try to be here so I record what I'm saying. Okay, so the question asks, what is the mass of 4.78 multiplied by 10 to the power of 24 NO2 molecules? First of all, you should be able to name this compound, and then you should be able to identify, is it ionic or molecular? Can anyone tell me in the audience what is this compound? Is it molecular or ionic? Why? Molecular, exactly. Why? Exactly, 2 nonmetals. Can anyone name it? Yes? Yeah? What is it? Exactly, nitrogen dioxide. When we have one atom at the beginning, we don't write mono, so it would be nitrogen dioxide, like CO2, carbon dioxide, right? So when we want to solve the questions, first we ask ourselves, what do we want to find? So what do we want to find?
Mass.
Exactly, so we write question mark grams of NO2, right? Equal sign to what we are given. What the question gave us? What information do we have?
4.78 times 10 to 10.
Exactly, so we write that. So this is the first step when we want to solve the question. For some reason it disconnects when I come here. Okay. So, and that is the number of molecules, right? This one, so you can write, number of molecules, or however you want to distinguish that this is the number of molecules, okay? Okay, so how can we convert number of molecules to grams? Do we have any direct conversion that converts grams to number of molecules? Exactly, we don't have any direct conversion, but we talked about a concept of Avogadro's number that I told you how we can convert moles to number of things. Do you remember what it was? Or like what was the number?
It's got a 6 in it.
Exactly.
6.
Okay, so what was the power? Do you remember?
It was the positive 23. 23?
Exactly. So even if you know that 6 multiplied by 10 to the power of 23, I think most probably you get the right answer because you have multiple choice questions, right? But the exact number is 6.022 multiplied by 10 to the power of 23. But like what your friend said, as long as you know 10 to the power of 23 and 6, chances are you get this, you can guess the answer between the things. So you know that 1 mole of anything would be 6.022 multiplied by 10 to the power of 23 of that thing. So you can write, you know that 1 mole of NO2 molecules has 6.022 multiplied by 10 to the power of 23 of that. So based on that, you should write a conversion factor, right, a ratio that in denominator we have something that cancels out with number of molecules. In numerator we should have 1 mole, right? Because this is how we define that, right? So 1 mole of anything is 6.022 multiplied by 10 to the power of 23 of that thing. So it would be number of, molecules in this example, right? Is it clear?
So I put the 6 point.
Exactly.
Okay,
And
that's what I
then,
thought.
exactly. Oh dear. Can anyone see that, or am I blocking the board? Okay. So this is not quite right because this is not grams. So 1 mole of anything is 6.022 multiplied by 10 to the power of 23 of that thing. So this is the number of molecules. Does that make sense?
Yeah.
So if I tell you I have 1 dozen of nails, what does that mean? That I have 12 of nails. So it's like number of nails, right? So that is more tangible example. Here you should write number of molecules.
Okay.
So it cancels out with molecules. Does that make sense? So now, and then you have like multiplication between them if you just put a dot or like, so make sure that you know that you're multiplying things, not adding or subtracting or whatever. So now this one cancels out with this one. Can you do, just cross them so your friends see that these two cancel out. Now we want to find grams of, NO2. And can you also write here NO2? Because sometimes you also should convert moles of the compound to moles of the constituent element, right? So write the compound or like a species that you have too, so you know you have one more step. And now you want to convert moles of NO2 to grams of NO2, right? So how can you do that?
Conversions are never my strong suit. I say that.
No worries. I mean, I'm here to help,
So would I put grams under here?
So, each step, when you're done writing that, you don't have to go back there. So here, you should add a conversion factor. You basically add a ratio, right? So if you see that this part, when you write this ratio, these two cancel out, and now you have moles of NO2. So you don't have
okay,
to.
so we don't have to do so
Exactly.
down here.
Yeah. You should. Yeah. You have an eraser.
Oh.
Yeah. Don't want to. Your hands become dirty. Okay. Now you want to cancel out mole. So you should write mole in denominator so it cancels out with the numerator here, right? Exactly. So can you cross out moles too? That we know that now moles of NO2, they canceled out. And now we want to find grams, right? Can you write gram NO2 in numerator? Okay. So now how can we convert grams, or how can we convert moles to grams? So if I ask you, what is molar mass of nitrogen?
Oh, it's 14 point.
Exactly. What is molar mass of oxygen?
15.99.
Exactly. So now if I want to find molar mass of NO2, how would you do that? So you know for nitrogen, you know for oxygen, right?
It would be added together.
Exactly.
So you would multiply oxygen by 2.
Exactly. Exactly. So you can just write it here. So you say NO2 equals nitrogen N multiplied by 1 because you have one nitrogen atom plus oxygen O multiplied by 2 because you have 2 oxygen atoms. And that is only what it makes sense, right? Because if you just add nitrogen and oxygen, these are like some of the answers. When I write your answers, I solve the questions wrong and put some answers, right, for you to choose mistakenly if you didn't know how to do it. But if you have like 2 nitrogen, it should be different from 1 nitrogen or like 100 nitrogens, right? Okay. Exactly. And what is the unit here? Exactly, grams per moles, right? So this number tells you 1 mole of this compound has this much of grams in it. So 1 mole of NO2 has 46.005.
That's the answer?
What's that?
Wait, that's the answer.
You just put this here too, right? Because it says 1 mole of NO2 has this mass, right? So, So now your answer would be, can you also write the final answer here? Or like have a ratio. It would be all of them. You should multiply those numbers, like 4.78 multiplied by 10 to the power of 24, multiplied by 1, multiplied by 46.005, divided by 6.022, multiplied by 10 to the power of 23, and that would be your answer. Does that make sense? So you wrote all the conversion factors, but if you don't multiply divide, you don't get the final answer, right?
So just kind of like rewrite.
Yes. Can you just rewrite that without the units? So
Yeah, okay.
yeah. Yeah, if your exam wasn't multiple choice questions, I would give you credits for writing each step, but fortunately or unfortunately, your exam is multiple choice questions, so I just give credit to final answer, 4 points to have the answer right. So, and I always encourage the students to also, after you put the number in calculator or before, kind of like calculate the numbers yourself too to make sure the answer makes sense, right? Okay, and the final unit here would be grams of NO2. Just write G gram NO2. Yes?
That's it?
That's it, yeah. I mean, unless, when in your exam you put the, number in calculator and then find the wrong answer, that would be really sad, but you got the question right.
How does this work?
Just like, yeah. Just press it. Yeah. Perfect. What is your name?
My name's Ella.
What's that?
It's
Ellie?
Ella.
Ella, okay.
It's, hold on.
Oh, good. Hi, this is you. Oh, that's so strange. Okay, you're also, I figured this out later.
Okay, thank you.
Huh. Anyway, so I all have the answer here, and I can go back here. So to kind of like paraphrase what your friend did, here we have number of molecules. Remember, you can convert number of molecules to moles. Okay? And I have more lectures, so don't leave if you can stay. And then you convert moles to grams by the help of molar mass. Okay? Any questions here? Everything's clear? Okay. And here is the final answer. I have another slide for the final answer. So the next part of this chapter that I briefly mentioned last session is mass percent composition of compounds. And sometimes in the problem, I can only, I can give you, and something that I mentioned, I wanted to tell this at the beginning of the class. Last session, I confused clover with leaf. So, I guess most of you knew, but didn't say. So, you can, anytime when I'm making a mistake, just feel free to tell me. So one clover has 3 leaves. So it doesn't matter for the purpose of our course because I'm not going to ask that. But in general, if I say something wrong, don't be afraid to tell me. Anyway, so sometimes I can just give you and tell you that sodium chloride, for instance, NaCl, is 39% sodium by mass. Can anyone tell me what does this sentence mean? Yes?
The mass of the sodium within the compound composes 39% of the mass of the compound.
Exactly. It means that if you have 100 grams of your compound, 39 grams of it is sodium. So sometimes you can convert gram to gram directly, but this is the only instance that I literally tell you mass percent composition of sodium in sodium chloride is 39%, or tell you sodium chloride is 39% sodium by mass. Other than that, you always convert grams to moles, moles to moles, moles to grams. Is that clear? Okay, and this is the formula. And as I wrote here, it's like section 6.6 in your book in case you're studying the book. So you have mass of your element, constituent element here, we name that X, divided by mass of the sample of compound multiplied by 100%. And you know what percentage means, right? If I say that 20% of the students got A in their midterm, it means that out of 100 people, 20 of them got an A. So this is just like percentage, nothing super complicated. Any questions? Okay, if question, I tell you practically when I give you molecular formula or chemical formula in general, how you should compute mass percent of the element. And here is the formula. Basically, you calculate mass of element X. If you want to find mass percent composition of element X, you calculate mass of element X in 1 mole of the compound divided by mass of 1 mole of the compound multiplied by 100%. For instance, if your compound is, I just hear people talking, any questions? If you want to find mass percent of Cl in CCl2F2, if you want to find mass of Cl in 1 mole of compound, you should remember that you have 2 Cl atoms. So you should multiply 2 by molar mass of Cl, okay? And divide that by molar mass of CCl2F2. And I hope you know by now how to calculate molar mass of a compound. You say C multiplied by 1 plus Cl multiplied by 2 plus F multiplied by 2. And then you go to the periodic table, read the number below the atomic symbol, and find the molar mass of this compound. And multiply that by 100%. Any question? So next class, I'm going to also solve problems, and then I ask you for your participation too. And I think it's a great way if you're lacking some grades, and if you want to increase your grade, this is a great way. So right after the class, I add points to your friends that they volunteered. And as you saw, you don't have to know everything, I just want to encourage all of you to learn. So, yeah. Okay. You're good to go. Yeah. I don't have attendance this session, so.